We are on chapter 5, and we're going to be talking today about the selection structure and a few little functions that we can use in our programs. So we're going to be looking at the selection structure. We're going to look at the pseudocode. We're going to look at a flow chart. We're going to look and see how we code it with C++. When using conditions, we use comparison operators like less than and greater than, and we use logical operators like and or. And then we'll talk about how we can temporarily convert some characters to either uppercase or lowercase. This helps us to compare characters that are entered by a user so that we don't have to make the user enter a specific case, whether it's upper or lowercase. And then we're going to look at how to format numeric output. So right now, the only structure that we've talked about is the sequence structure. Remember, there's 3 structures that we're going to cover: sequence, selection, and the one for looping, the loop structure or iterations. And so what the selection structure allows us to do is to add some decisions, to make some decisions in our program based on some condition before selecting an instruction to execute. A selection structure's condition must be phrased as a Boolean expression. So it has to be phrased, it has to evaluate between true and false. So that's why we use the less thans and greater thans and or the Boolean operators. So here are 2 different flowcharts of a particular problem. This problem, the pizza place wants to display an employee's weekly gross pay given the number of hours worked and the pay rate. The employee working more than 40 hours is paid an additional 1/2 of their hourly rate. So if you work up to 40 hours, you get your regular pay. More than 40 hours, so 41 or 40 and a half, 41, 42, gets time and a half. So our first option here, this first flow chart, we have the user enter the number of hours they worked and how much they get paid per hour. Then we calculate the pay, hours times the rate, and then we check the hours. If the hours is over 40 hours, then the gross pay is going to be different. It's going to be the gross pay plus hours minus 40. So here we figure out how many overtime hours they worked, and then we multiply those overtime hours times the rate divided by 2. And we display the gross pay. If they did not work any overtime, then it's false and we don't do anything. So we take this path and we just display the gross pay because we've already calculated it up here. So we don't have to calculate it. This is one way that we could solve it. Another way is we ask for the hours and the rate, and before we do any calculation, we find out if they worked overtime or not. So right at the very, very beginning, we make a decision and we ask a true or false question. Is the hours that they worked less than or equal to 40? If it's true, if it's less than, so no overtime, it's just a simple calculation. If they worked overtime, then they're going to get paid time and a half. And then whether it's true or false, we're going to display the output. So this is a flow chart A lot of times we'll create flowcharts not only for coding, but in real world situations. We'll also create flowcharts for data. Like we want to see the flow where the data is being sent, and making sure that we don't cause any problems to the data. So it could be flowcharts for data, it could be flowcharts for programs also. And looking at this, I didn't go over this before, but when you read, I think it was chapter 2, it talked about the different symbols and the shapes. So the parallelogram here is always going to be your inputs and your outputs. These, I guess we would call ovals. Not really sure what to call this shape here, but that will be always our start and our stop. And then the rectangles are always going to be the calculations. So calculations are rectangles. The diamonds are always the conditions. So diamonds are always conditions. And those are all the ones that we've looked at so far. The shapes. And it's the same in any flowchart. Will be these shapes. Okay, so to code the selection structure in C++, we're going to use the keyword if and possibly the keyword else. You don't have to use the else. You could just have an if without an else. If is lowercase. After if, you have to have parentheses. And inside the parentheses, you're going to put your condition. And our condition, like example earlier, was if the hours are greater than 40. And then inside the if, you could have one or more statements in here. And then you have the else. Again, you don't have to have an else path. It is not necessary, which is why they put brackets here. And again, you can have one or more statements if it's false. So the keyword if and the condition are required. And then everything in brackets is optional. So this is required. Programmers must supply condition and statements in true and optionally false path. If the path contains more than one statement, you have to use what's called as statement blocks enclosed in the open and closed curly braces. Good programming practice, you would put a comment at the end of your clause. So you would put it in end-div just to let us know where it ends, and makes it easier to read. And your condition, of course, has to be a Boolean expression. It has to result in a true or false statement. Your conditions can contain variables, constants, arithmetic operations, comparison operators, and logical operators. And we'll look at some examples with all of these. So here's the syntax. Here's one option. So that first option would be if, condition, and just one statement, and then end if. Another option would be if the condition is true, I want to have multiple statements. If I'm going to have multiple statements, then the only difference between these two is that I have an open and a curly brace. And that's to enclose all the statements that will happen if this is true. If I don't enclose them in the curly braces, only one statement happens. Well, everything happens if true, but the second and following statements will happen even if false. And that's confusing, but I'll show you in a minute what that means. Okay. So here's another way that we could write an if statement. We could say if true, one statement, else one statement. If true, one statement, multiple statements, so I've got to have the curly braces, else one statement. if true, one statement, else multiple statements if false. Gotta have the curly braces. Or I have multiple statements for both true and false, and I gotta have both curly braces. So let's just stop there for a second, and I want to show you using namespace standard. Okay, so let's say that I have an integer and num equals 40. So if I say if num is greater than 40, then cout 40. So I just run this. And oh, it's not greater than 40. Okay, I was like, and I get no output. And that's correct. I get no output because the number is not greater than 40, so there's nothing to do. I didn't give it an else statement, so it didn't do anything. So now I want to have an else statement so that it will do something. Cout not greater than 40, because it's actually equal to it, right? It's not greater than. Okay, so now it tells me not greater than 40. So this is one statement. Now, if I want to have two statements, so for example, I want to cout num also, and del, and line, so that it would print out the number and then it prints this line. It's not going to run if I don't put my curly braces. So it gives me an error and it says else without a previous if. So right here is the else. And the reason it says there's not a previous if is because it's expecting the if to be right here. So it would be if cout else cout. So that's why it gives you the error that it does. So we're going to put our curly braces, open, close, and let's not forget our comment so that we know that that's where it ends. Comment is not needed, remember. Okay, so now this is not greater than 40. So let's make it greater than 40, 41. And it'll print the 41, and then it prints greater than 40. Once again, if I want two statements in the else, I gotta have the curly braces. And by the way, I can always put curly braces even if I only have one statement. So I can have curly braces even if it's one statement, but it's definitely required if I have two or more statements. Now, here's what happens if let's say that if it's greater than 40, I want to cout these two lines. Well, if I don't put my curly braces, here is what will happen. So right now it's greater than 40, right? So it's 41. So what it's going to do, it's going to print, it's going to say if this is true, which it is, it's going to print out 41, and then it's going to cout greater than 40, which is still what we wanted, right? 41 greater than 40. But now if we make it 40, which makes this false, it skips this line because it's false, and it prints this line, which is not what we want. So it prints greater than 40, which is not greater than 40. So here we're just missing our else statement. Okay. Now, something that you might see with some people coding is that you might see that they put their cout right here next to the L's, that's valid. You don't have to put a space. You don't have to put it on the next line. It's just the way that in C++ we format our if statements. But in other languages, you'll see that it's right next to the else. And so then you'll see some people coding in C++ this way. Okay, so that's our if else. The curly braces is what's going to get you and really mess up your code if you don't get those correctly. So at the beginning, if you're a beginning programmer, maybe just put curly braces on everything so that you get the correct expected, or the expected output. All right, so let's keep slideshow. Let's keep looking at these. So the comparison operators that we're going to be using are the less than, or equal to, no space in between these, greater than, greater than or equal to. If you want to compare to see if two things are completely equal, we have to use two equal signs, because remember, one equal sign means assignment statement. So this also is something that gets students. Comparing, you got to use two equal signs. Exclamation point with an equal sign beside it, no space, means not equal to. Exclamation point means not in C++ and Java too. So not equal to. So maybe you want to say, if the letter is not equal to a P, because you were expecting a P, then ask them to enter the letter again. Okay. This is a chart of the precedence number. So the precedence operators have precedence just like the arithmetic operators. So the comparison operator, less than or equal to, greater than equal to, all have precedence 1. And then these have precedence 2. So if you see all of these, or if you see some of these and some of these in a problem, then it's going to evaluate these first, and then it evaluates the equal to and not equal to second. Here's some examples of some comparisons. Quantity less than 50. Is age greater than or equal to 25? So for this one, it would be true if the age is 25, or it would be true if the age is 26, 27, 28, and above. Anything 24 or less would cause a false statement. Here we're checking to see if these two variables have the same value, hold the same value. So is on hand equal to target. So whatever those two variables hold, it says that they hold integers. So if this integer that's stored in that variable is equal to this integer stored in that variable, then this would produce a true statement. For this one, it says, is quantity not equal to 7,500? So if the quantity is anything except for this particular number, then it's going to not equal to 7,500. Then it would produce a true statement. And then there's a little note down here saying to keep in mind that equal is the opposite of not equal. Greater than is the opposite of less than or equal to, and less than is the opposite of greater than or equal to. We talked about precedence earlier, and one thing I didn't mention is, just like with our arithmetic operators, parentheses used to override precedence order. So we'll still use those parentheses. And sometimes we'll use parentheses just to make it really clear for whoever's looking at our program of what order we want things in. Expressions with comparison operators always evaluate to Boolean values. So what it's saying is that it always evaluates anything with less than, greater than, all that, evaluates to a true or a false. Now remember not to confuse two equal signs with one equal sign. This means equality, this means assignment. Don't use equality or inequality operators to compare real numbers. Real numbers cannot be stored exactly. Instead, you're going to test the absolute value of their difference. And we'll look at some examples probably here. If not, in your book, they'll have some examples of where they use the absolute value function. There's an actual way to figure out the absolute value. And here's an example. So if we have arithmetic operators and comparison operators, then all the arithmetic operations will happen first, and the last thing that's going to happen is comparison. So we're going to do 7 minus 3 plus 8. Calculate that first. So 7 minus 3 is 4. 4 plus 8 is 12. Then it's going to add 9 plus 5 and give us 14. And lastly, we compare, is 12 less than 4? Okay, so we do this first. Then we add the 8 is second. Third, we add 9 plus 5. And fourth, we compare 12 and 14. All right, so in the next slide, I'm going to show you some code on how do we swap numerical values. Whenever we have to swap two numbers or two memory locations, it can be numbers or it could be characters, it could be strings. So we're swapping two memory locations. We always have to create a third memory location. And we call that a temporary variable. Okay, so this is the code, but before I show you the code, I want to show you this here first. So let's say that we've got two scores, 99 and 84, and I want to swap these. I want to put the 84 here, and I want to put the 99 here. Well, I can't just assign score 2 to score 1, because if I do that, it gets rid of the 99. 99 goes away. So if I assign score 2 to score 1, I'll have two 84s, and my 99's gone forever. So what I have to do is I have to create a temporary variable, set it to 0. I'm going to take my 99 and I'm going to move it to that temporary variable. Okay, so I'm going to keep it safe there. So I'm going to assign score 1 to temp. And now temp has 99, score 1 has 99. Once I do that, I can take my score 2 and move it to 84. So now I have two 84s, which is fine. I still have my little 99 over here saved. And now I can override this 84 with the 99. So to swap, we have to have the temp variable, so we'll hold one of the values, and then we can do our swapping. So here's what the code would look like. We would have the user enter the two scores, and then they're swapping if score 1 is greater than score 2. So if score 1 is greater than score 2, they're going to do the swap. So they create a temporary variable. They move score 1 to the temp variable. Now that you move score 1 to the temp variable, you can change score 1. You can overwrite it. And so you write it over with score 2. And then now you take the temp and you put it into score 2. Now notice that they defined their temp variable inside this if statement. It wasn't defined up here. If you define a variable inside a block of code, so inside this if statement, you're not going to be able to use this variable outside here. So if you try to see out temp here, it will give you an error and tell you that it's not defined. Just, just something to make note of. If you defined a variable inside a block, you can only use it within that block of code. So this is just looking at the flowchart for swapping. So basically you have the condition here. If it's true, you swap. If it's not true, then you just don't swap and you display the values. Now, swapping is important. The reason they're showing you swapping is that in coding, a lot of times you have a lot of data and you have to put data in order. Maybe you have students and you have to put them in alphabetical order. So that requires swapping. Maybe you have scores and you want to find the lower score. So to find the lower scores, maybe what you do is you put them in order and then you take the last score and that's your lowest score. And so swapping happens a lot whenever we're gonna search for data. We have to sort the data. Data has to be sorted so you can do search. So if you think about when you go to a store and you forgot you've lost a receipt and they're searching for your purchase, well, all that data has to be in order, because if you enter let's say a person's last name or your customer number pulls it up, or your credit card number, there's got to be something that makes it easier on the computer to search. They can't just search each transaction that they've had for the past 90 days. Otherwise, it would take forever. Displaying the area of circumference. Okay, so circumference is circumference of a circle is if you have a circle, it's the so we have area or the circumference. So you have the area of a circle, so that would be all the inside part of the circle, and the circumference is if you walk around the circle, how far is that? So I apologize for the algorithm. For some reason it goes crazy, but you can see this in your book, figure 5-11. It has the IPO chart, but really I'm really just concerned about the C++ instructions. And so here we're just going to look at some things that they did and review a little bit about what we talked about in the previous chapters. Here they defined a constant, so double pi equals 3.14. They defined a radius, assigned it to 0.0 because there's a double. And then they have an integer called choice. We'll see what that's about in a second. And then they have the output is answer. So the user enters the radius and then they're asked for a choice. They can enter 1 if they want the area of the circle, or they can enter 2 if they want the circumference of the circle. So if they enter 1, then it's going to have a certain calculation, which is the calculation for the area. And if they enter 2, they'll have the calculation for the circumference. So here's your if statement. If choice is equal to 1, 2 equal signs. Choice is an integer. 1 is an integer. These two data types have to match. If this is true, then answer equals radius times pi. So if you recall the formula to find the area of a circle, is pi r squared. So r squared would be radius times radius. And then we output the area. See out area. This is going to print area colon space, and then the answer, the area of the circle, and then a new line, ENDL. Remember, this is an L. Our if statement has open and close curly braces because we have two statements for the true. If choice is not 1, then they entered something else. Now they could have entered a 2, a 3, a -1, a 4. We're not really checking that they enter a 2. We're just checking that they enter something else. So here you have to decide, do you want to check exactly for a 2 and tell them that they, give them an error if they entered anything else? That's up to you. You're writing the program. So we figure out the circumference. Circumference is 2 pi r. So 2 times the radius times pi. And then we output circumference. Again, we have our open and curly braces, open and closed curly braces. We have a comment to have a nice commented program that's easy to read. We've indented here. These are not required, but again, it's just so that we can easily read programs. And I keep talking about reading programs because in a real programming environment, you have people who actually look at your code and give you feedback on how you've written your code. So you'll sit around, you'll share your code with people, and they'll give you feedback like, your feedback of variable names, feedback about your spacing, feedback about your comments, so your techniques, things of that nature. Okay, so this slide needs to be deleted from here because this is not our circumference program, but that's okay. I'll take it out. Okay, displaying the area or circumference, here's how the flow chart would look. So here's where you would have the condition. If it's true, you have a rectangle that has the assignment statement, and then your output is in a parallelogram. Same thing here for false, it's just a circumference. They all come down to stop. Okay, logical operators. We have two logical operators, the AND and the OR. And they're also called Boolean operators. They always evaluate to a true and false. All subconditions must be true for a compound condition using AND to be true. So if you use AND, both sides, both the left and the right side of your condition have to be true for it to be true. If you're using an OR, only one of the conditions has to be true. So I can say, if your name is Joe and your social security is 452156327, then I'm going to let you in. So you've got to be Joe and you got to have the social security number, Joe Smith, let's say. And so both conditions have to be true. But an OR would be something like, okay, if you are a male or you were born in the 1980s, then you're qualified. So you can either be male, so all males would be allowed. They would be qualified for whatever it is that they're getting qualified for. If they're not males, if they're females, then they have to be born in whatever year I said. I think I said the 80s. Okay? So only one has to be true. And is always evaluated before or, so it has precedence over or. So if you have this and that or this, then and will be evaluated before or. Logical operators are evaluated after arithmetic and comparison operators. So first arithmetic, then comparisons, then logical operators. Again, parentheses can override the precedence. We have a truth tables that I'll show you in a second that summarizes how computers evaluate logical operators. And only necessary subconditions are evaluated. So this is called short circuit evaluation. Short circuit evaluation is used with an or, let's say an or statement. If you have an or statement and the first part is true, then you don't need to look at the second part, because with an or, only one side has to be true. And with an and, if the first part is false, you don't have to look at the second part, because in an and, if one of the sides is false, then everything is false. So that's short circuiting, and it makes processing faster. Just does it automatically. So here's an and, here's an or. And has first precedence, so we do that first, or we do second. And here's an example of using and or. So if the population is greater than 2,500 and the population is less than 5,000, then it's true. So the population, here we're checking to see if the population is 2,501, between 2,501 and 4,999. And here we're checking for an age. The age can be equal to 21, or the age can be greater than 55. So let's say you're 22 years old. So if you're 22 years old, then this would be false, and this would be false. If you're 21 years old, this would be true, so the computer wouldn't even look at this. There's no point, because this is true. You have an or, only one side has to be true. If quantity is less than 100 and price is less than or equal to $10.35, then it's a true statement. So both of these have to be true. Quantity has to be less than 100 and the price has to be less than or equal to $10.35. Here we're using an and an or. We're going to evaluate the and first, and then we'll evaluate the or. So this has to be true. Both of these have to be true to get a true statement here. If both of these are true, then you have true or whatever. You really don't have to look at the price. So if the quantity is between 0 and 100, then it just automatically does whatever it's going to do. We don't even have to look at the price. Hope that makes sense. So let's say quantity is 5. The quantity is greater than 0. It is less than 100. True. We have an or. Do we even care what the price is? No. Because with an or statement, it's or. It's either this or this. And we've got this to be true, this side. Now, if this comes out to be false, let's say quantity is 110, and so this makes this false. So then the program, the compiler, does have to look at this side, and it has to look at the price and check to make sure the price is greater than $34.55. This is the truth table, and there we go. And it's basically what we talked about earlier. So So what it's saying is if you have an and right here, and this side of the and is true, and this side of the and is true, then the whole condition is true. If this side of the and is true, but this one is false, the whole condition is false. If this side of the and is false and this one is true, well, if this side of the and is false, we don't even evaluate the right side. It's just false. Again, if this one's false, we just get a false. So with an and, everything will be false. Everything will be false, always, always, unless both conditions are true. Opposite with the or, everything is true unless both conditions are false. If both conditions are false, then you're going to get a false. It's going to return false. And I just went over that. So here, this is the order of operation. Okay, so if we look at this, and this is something that you will have to know and be able to do on quizzes and exams. Also, Boolean operations, you need to know how to use those. So if we look at this, remember, first we do all arithmetic calculations. So I start here. I don't do this. I don't compare. But I see a division, okay? And I see a plus. I see multiplication. So order operation tells me that division and multiplication come first, and then addition comes after that. So I'm going to divide first, 80 divided by 2, and get 40. That's my first step. I'm not going to add yet. I have to multiply first. So 10 times 2 is 20. So now I'm here. I've got 40 plus 3. I have one more arithmetic operator to evaluate. So 40 plus 3 is 43. Now I have a less than, I have a logical operator, and I have a greater than. So my less than and my greater than come first. Less than and greater than have the same precedence. So I'm just going to do this one first. 20 less than 43. Yes, that's true. 20 is less than 43. So I get a true statement. Then I look at this side. Is 25 greater than 20? Yes, 25 is greater than 20, so I get a true. A true and a true is a true statement. Okay, this is the only way you can get a true with an and, is if both sides are true. If this would have been false or this would have been false, then this would have been false. This is a little table for you to study and keep. This is the precedence number of all, starting with our arithmetic operators all the way down to our comparison and then our logical operators. Here's an example of calculating gross pay. So I think earlier we were looking to verify, we were looking at gross pay, we were calculating gross pay, but here what they're wanting to show you is how to verify data. So you're asking the user to enter the number of hours that they worked. Let's say that the hours that they entered had to be between 0 and 40. So they couldn't enter anything less than 0 and they can't enter anything greater than 40. So we call that data validation, and when we verify data, we use conditional statements. We use if statements. So here's an example of where they validate the data. Here we're going to say enter hours worked. It has to be 0 through 40. They see in the hours worked. They get the input from the keyboard. Then they compare. They say, okay, is the hours worked greater than or equal to 0? And is it less than or equal to 40? You got to have the equal signs, otherwise you're not including the 0 and the 40. If that's true, then you calculate their gross pay, but if it's false, you give them a little error message saying you've entered incorrect number of hours. So you're not going to allow them to enter negative numbers or 41, 42, 43 and above. So this is using the logical operator and. So let's say that you want to use the logical operator or. So if you're going to use the or, then you would say if the hours are less than 0 or the hours are greater than 40, then you give them an error message, else you calculate. So basically it's just the opposite. These are opposites of each other. So study this more, take a look at it. Ands and ors can cause a lot of problems for students trying to understand. You just need to give yourself time and do some practice problems. All right, so let's take a look at two functions that C++ gives us. One is to upper and to lower. These functions are used to convert characters so that when you compare characters, you can compare to either an upper character or a lower character. This makes it easier when you ask users to enter things like answer Y or N for yes and no, or the program, the lot that you'll be creating. You're going to ask not only you're actually going to ask for them to enter if they're male or female, so M or F, and you're going to ask for them to enter if they're active or inactive. It's a calorie calculating program. So they'll enter an A for active, I for inactive, M for male, and F for female. And so let's see if there's an example of how to use this. Here's an example. So if toUpper, so toUpper is a function, and it's a key. It's you have to use it lowercase, just like this. Because it's a function, functions have parentheses. You pass the variable to the function that you want it to convert to upper or to lower. Now, you're not, when you say toUpper senior, so it takes senior's going to have a yes or a no, a Y or an N, to say if they're seniors, citizens or not. Let's say that they typed a Y, a capital Y. I'm sorry, a lowercase y. If they typed in a lowercase y, then it converts your y to a capital, because you said to upper, but it's in a temporary location. It doesn't really alter your variable. So your variable senior doesn't get altered. It just creates, toUpper creates a temp variable, it converts it, and then it compares it to a capital Y. So here's toUpper, toLower. So if you want to compare two lowercase letters, you can. Whichever one, it doesn't really matter. And then lastly, we're going to look at how to format our numeric output. So a lot of times you'll get lots of decimals after numbers, and really all you want is two numbers after the decimal. And so here's how we can do that. So we have this sales amount that has this number, and we see out fixed. So fixed is actually a keyword. And so when we see out sales, it's going to actually give us the entire amount of decimals allowed for a double. So it's going to have 25 and then 1, 2, 3, 4 zeros after. So if you have this number 1, 2, 3, 4, 5, 6, 7, and you do fixed, it's only going to display 6 numbers. So fixed just displays 6 numbers after the decimal. So here we have 1, 2, 3, 4, 5, 6. Notice on this one, we actually, when you use fixed and you output rate, it rounds this number based on this one. So the 3 goes up to 4 because this is a 6, so it rounds up. So if you have a 5, if you have a 5 here or greater, it's going to round this number up. And then you can also decide if you want to show the numbers in scientific notation. So maybe for some reason you're wanting to do that, and then you put in the keyword scientific before you actually display your sales amount. So we call this stream manipulators. This is a stream of characters that you're going to output. You're outputting it to the screen because it's console output. And these are just 2 keywords that you can use to manipulate your output. We have a function called set precision, and set precision will allow you to decide how many numbers you want after the decimal. So if you wanted to display, let's say, money, then you most likely want to have 2 numbers after the decimal. Or averages. Maybe you just want for an average, you wanted 1 number after the decimal. So this example here, we have 3,500.6. We're going to say fixed so that it gives us the extra 5 zeros, and then we're going to set precision to so that it gives us 0.60. If we don't put fixed, then we're not going to have that zero, that extra 0 there. So set precision 2 means 2 numbers after a decimal. Set precision 3 numbers after the decimal. Set precision 0, it will round and give you no numbers after the decimal. So something like this would be good when we're working with averages, like when I do averages for students. If I have a 0.5, then this number will go up, right? So your grade's going to go up by 1 point. So I can get rid of the decimal and also round up if I need to. Okay, so that's the end of this chapter. For your lab, you're going to be creating a program. One of them is creating the program where you're calculating number of calories that you should have per day, depending on your weight and whether you're male or female. And so you'll be using some conditions, if else statements, and you also need to use the to upper or the to lower in your program. For this program, you will not be needing the set precision function or the fixed function or the fixed keywords. Okay, good luck with your program.